Why is it that finding answers always seems to lead to more questions? Wait, don't answer that yet. When it comes to sensing and measurement, perhaps it's because once users realize they actually can get one type of answer, it sparks their imagination for finding others. Hi, I'm Jim Montague. Welcome to Part 1 of Control Design's 2010 Market Intelligence Report on Sensors and Vision. Though regular vision-based and wireless sensors continue to expand their relative presence in machine applications, there are some ups and downs in how often they're applied. To better understand these trends, we've once again surveyed Control Design's readers to get a snapshot of the types of sensing components they employ on their machines and production lines, including those that use machine vision. The first section of this two-part video will look at the sensors, and Part 2 will examine vision-based sensing. We've also asked Ned Lecky, founder of Lecky Integration in Little Falls, New York, to come back and provide some fresh context and analysis of our survey results for 2010. Lecky is a mechanical engineer and electrical engineer with 25 years of experience in control systems and machine vision. As owner of Lecky Integration, he consults for OEMs, system integrators, and machine vision providers. We'll ask him for a system integrator's interpretation of our findings right after this message from our sponsor. Welcome back. No huge technological changes have shaken the world of sensors and machine vision since we first conducted this survey in 2008, and the pecking order of sensor popularity and selection is largely unchanged. So, Ned, while the economy might be slowing some new deployments, is sensor technology overall still advancing faster for some sensor types compared with others?
Well, Jim, absolutely. I think it's fair to say that the technology advancement in all of these sensor areas is pretty astonishing. I mean, we see tremendous growth in all the different types of photoelectric sensors. Certainly the imaging sensors and cameras are taking off like crazy, largely fueled by the growth in consumer imaging kind of systems and cameras. But certainly in the area of proximity sensors, rotary encoders that we use all the time in machine control, positioning applications, that sort of thing. We're seeing all kinds of reduction in cost and increases in accuracy in all of those sensor areas. But I guess I would have to say of all of these sensors, the one that is seemingly advancing the fastest right now clearly is the machine vision sensor, the cameras. And in some sense, I guess I would say it's just because that was the one that had the most catching up to do. Many of these other sensor areas are approaching kind of a level of maturity. They're very easy to integrate. People know in general how to tie them into all different kinds of systems, whereas we're still seeing this rapid growth in the machine vision sensor kind of camera area. And some catch-up is definitely taking place.
Okay. Now, 2010 revealed a drop-off in the use of hardwiring to connect sensors to I/O points. Just 57% of the 2010 respondents report using hardwiring, while 78% of them used it in 2009. Consequently, it follows that 15% reported using device-level digital networks in 2010, almost 10% used Ethernet this year, and 7% used serial 232/422/485 networking. These were all upticks from prior surveys. Ned, is this a new generation of control system designers choosing a more familiar digital network, perhaps along with recognition by experienced designers that digital networks do have advantages over hardwiring?
Absolutely. I mean, the biggest cost in installing a sensor is often the wiring of the sensor back to the system that it is reporting its data to. For a lot of people who are in the academic market or even some of the component vendors, they might not necessarily realize this. But if you're running wire through hard conduit and you've got to run it 60 feet through a noisy factory environment, and especially when you're using expensive, highly skilled labor to get all of that wiring done, it's not uncommon for the $150 sensor to need $2,000 worth of wiring if it needs to be hardwired back to a PLC somewhere. So there are huge benefits to taking networks of sensors, tying them together to some sort of aggregators, and then using digital communication networks to get the data back from those aggregators to the central computer, whether it's a PC or a PLC or some other kind of controller. In the beginning, we saw a fair amount of this being done with very proprietary networks. And now, just because of cost and reliability, certainly I think Ethernet is the one that really seems to be the grand unifier. We're using gigabit Ethernet now, not only for digital I/O and analog I/O and control signals to a motion controller, but we're even using it for our live video data with the advent of gigabit Ethernet cameras. So now with one Ethernet network, we can take every sensor in the system, including all the cameras, and pull them back to a computer with no additional wiring. And on top of that, with power over Ethernet, it's a way to get power to the sensors or even cameras just using the Ethernet cable. That's another huge cost reduction for the integrator in getting these sensors up and wired. USB is a digital network that's been used in this way. There's 5-volt power available on USB, but you don't have a long enough cable run with USB or even something like FireWire really to handle the general purpose machine building environment. In gigabit Ethernet, we can go out to 100 meters, we can bring data, we can bring power. It's a huge attraction to the machine builder and the system integrator.
Similarly, despite Ethernet's gains, there seems to be less pioneering on the wireless front as well. In the 2010 survey, only 25% of respondents say they use wireless connectivity in any of their sensors, while 3/4 say they don't use wireless. This too was a decline from 2009, when 30% of respondents reported using wireless for their sensors, but it's about even with the 25% that used it in 2008. Of those that do use wireless for sensing in 2010, 48% use it in places where it's just too difficult to run hard wiring, 22% use it for rotating equipment, and 13% they say they use wireless because it allows cheap sensing and measurement of variables that wouldn't be done otherwise. These seem to be pretty clear advantages for using wireless. So Ned, is this year's reversal in adoption rate as much about the economy as anything else? Do you think progress is being made in the understanding and ease of deployment of wireless sensing?
Well, I'm a big proponent of wireless sensor networks. It's much easier to run no wire than it is to even run that gigabit Ethernet wire. So there's some wonderful advantages there, and certainly in jobs that we've done in the past, we've run into situations where it's either very inconvenient to run the wire, we've got outdoor applications or a number of different remote sites, or you need to have a system that is rapidly deployable. Sometimes we'll get in systems that need to be set up very, very quickly. It's very convenient to have 4 cabinets that are communicating wirelessly and not have to run all kinds of communications between them. That said, there are more things that can go wrong with wireless communications than there are that can go wrong with wired communications in most environments. If you don't have rotating equipment and things that are moving around, frequently or with high acceleration, then in general your simple cable interface is going to be more reliable than the wireless interface. In high noise environments where we have big motors, arc welders, things like that, the wireless, in spite of all of its advantages and its noise immunity, is still not going to be as noise immune in general as shielded twisted pair or a nice solid cable. So I certainly think that some of the fall off in wireless adoption may be driven by the economy. But I also think that the situation is that the bulk of the applications out there for sensors don't really require those specific advantages that wireless offers. That's been my experience with it in any case.
Ned, thanks again for helping us make sense of the results in our Sensors and Vision survey. We really appreciate your putting it in context and sharing your analysis with other controls engineers. And to all you folks out there, don't forget to watch part 2 of this video for our survey's results on vision-based sensing at www.controldesign.com. I'm Jim Montague, and this has been another Control Design Market Intelligence Report.